We're skipping exercises 2A and 2B from this textbook, mostly because they're not in the syllabus. Everything they teach you we've either done or we can do when they become relevant. For example, I trust that you guys know that whole numbers can either be prime or like composite. So composite is when you times other things to get them. They can be rational, which means they can be turned into fractions. You can add them together, you can divide them, and I trust that you guys know how to do that. I trust that you guys know how to deal with decimals. We've done that so much. Percentages, we're not going to bother. Yeah, you know how to round. Scientific notation, that is important, but they teach you it in physics, chemistry. It's not in this course. You'll also learn it again if you do standard. There's a nice proof that the square root of 2 is irrational. I actually hate that proof, to be honest. I'm going to go through that in class, but you don't need to understand it. You're welcome to read it. It's on page 43. Again, you don't need to understand it. Intervals, we're going to go through that when we do functions. I don't like where it is in this textbook, so we're going to learn it later. So we're skipping all of that exercise. We're on to 2C. Surds, everyone's favourite. How absurd. Square roots, cube roots, nth roots, whatever. So surds are pretty much anything that can't be like simplified. They still have that root sign. So for example, here you've got the root of 4 over 9. Well, we know that the square root of 4 is 2, and we know the square root of 9 is 3, so this actually equals 2/3, so it's not a surd. Cubed root of 8, well, what times itself 3 times equals 8, 2 times 2 times 2, yep, so that's 2, that's not a surd. Laws concerning surds, well, you forgot the square root of something squared, you like square root it, obviously, so if I had the square root of 25, it'd come out as 5, because 25 is 5 squared. Same thing, if I try to square it, if I square the square root of something, for example, the square root of 5, if I had root 5 and I squared it, root 5 times root 5 comes out as just 5. When we multiply with square roots, like we can put them together, we can also undo this. So if one of these was a nice square number, like 4, if this was 28, which is 4 times 7, then that's root 4 times root 7, and root 4 is just 2, so it's 2 times root 7 or 2 root 7. We'll do this in more detail later. Same with these. And when we simplify, we try and take out a square number, 1, 4, 16, 25, 1, 4, 9, 16, 25, 36, 49, etc. That should be the first thing you look for. So if we go through and have a look, sorry, let me get rid of this because it's hiding my stunning face. If we go through and actually have a look at this first example, we are going to simplify these expressions. So 108. I go through my list of square numbers, and I'm just going to write them up the top. I've got 1, 4, 9, 16, 25, 36, 49, 64, 81, I always get stuck there, 100, 121, 144, 169, nice, and it keeps going. So 108, do any of these go into that? Does 4 go into that? Does 16? I wish I had my calculator here. 36, I think actually, 36, 72, 108, yep. So root 108, let me get some paper. Sorry, I'm not set up for this yet. There we go. So root 108, I can actually rewrite root 108 as root of 3 times, what did I decide it was? 3 times 36. Which means I can separate this through 3 times root 36. And I know the square root of 36 because it's 6. 6 times 6 is 36. So I've got root 3 times 6. So another way to write that is 6 root 3. Root. B, it asks us to simplify 5 root 27. So we've got 5 out the front, that's fine. 27, 9 goes into that. So I've got 3 times 9. which means I've got 5 root 3 root 9, and I know what root 9 is. It's actually 3, 5 times root 3 times 3. Now I see that this is a normal number and this is a normal number, so I'm actually going to put them together. 5 times 3 is 15, so I've got 15 root 3. And it's 15 times root 3, 15 root 3. Like with algebra, I'm not going to bother writing times. Root 216, that's not B, that's C. I really wish I had my calculator here. 216. Well, I know 4 goes into that, because 4 goes into 200 and 4 goes into 16. I'm actually going to divide that by 4 and see. Like 16 may go into it, but let me see. Well, 200 is 50 times 4. 16 is 4 times 4, so 54. No, 16 is not going to go into it. 36. You're going to crank through these on your calculator. And I'm going to cheat. 216 divided by 4. 54, okay. 216 divided by my next one to try is 9. 24. Ooh, that's cool. What's my next one? 16? No good. 25. Well, that's not going to go. 36. 6. And because we've now gotten a small number here and it's not square rootable, I know I'm finished. 36 and 6. Yep, okay. So let me hide this one. So I'm going to rewrite this as 216 equals the square root of 36 times 6. I'm going to separate them. Root 36 times root 6. Root 36 is just 6. And that's just 6 root 6. Okay, example 3, looking at these questions, you can only add and subtract surds when it's like algebra. You've got to have your like terms, like x plus y you can't do, but x plus 3x you can. So with this first one, example A, we've got root 44 plus root 99. I'm going to simplify this as much as possible. So I know root 44 is 4 times 11. Root 99 is 9 times 11. I can separate these. Root 4 times root 11 plus root 9 times root 11. So I've got root 4 is 2, root 11 plus root 9 is 3, root 11. So I've got 5 root 11, because 2 plus 3 is 5. Let's have a look at B. Root 72, 9 times 8, okay. Or 36 times 2. So I've got root 36 times 2, take root 25 times 2, plus root 4 times 3. I'm not going to bother doing my second step. Root 36 is just 6, so I'm going to take that out the front straight away. Root 25 is 5, I'm going to take that out the front. Root 4 is 2, take that out the front. Now, see how this one's got a root 2, this one's got a root 2, but the last one does not. That means the last one's not a like term. 6 root 2 take 5 root 2 is just 1 root 2. And that plus 2 root 3, nothing I can do with it. There we go. That's simplifying surds. It's fairly simple.